Yeah.
No, that no, text is not like this. Not like when you use it, right? And then like.
Okay, guys, yeah, let me go over the calendar. Monday, I went over solving trig equations. With the factoring, with the Pythagorean identities, with the double angle identities. Really, you're just trying to apply the identities in a way that will allow for your trig equation to be solved. And we went through 2 sections Monday because yesterday there was no class. We should work through the odds, and we can always go back and work on the evens if we want that extra practice. So today I want to cover 2 sections, but really we're just continuing on with the same types of things. It's just that we're, applying. If there's a need to apply a sum of difference identity, then we apply it, and then we just continue cleaning up the same way that we've been doing in the past 2 days. Multiple angles, equations with multiple solutions for the angle. We can practice through that as well, and work through those types of problems. So I want to cover 2 sections today, just because I know that there are some students who may want to take a test early. So if I might just cover all the new material, then you can have an easier time kind of reviewing through everything if we cover everything. So I think by today I should cover most everything. Principal values, we're going to go back and review that a little bit tomorrow, but we'll be able to have Friday as a full class day to review. I have a review worksheet, test review worksheet, a test review worksheet for Friday and for Monday, and then Tuesday is your test. Your test is just over solving equations. Okay, so it's not going to be any of the calculator problems from the previous quiz. Okay, so it's just this week. I just want to get an idea. If you change your mind, we're welcome to do that. So I just want to get an idea. Is there anyone who is thinking of taking the test earlier than Tuesday? And if you want to show your hands, and if you want to, I just want to get an idea, because if you change your mind, that's fine as well. So, okay, so most of us are probably going to take it on Tuesday. If you do want to take it earlier, just come talk to me and we can figure out the time, either before school, lunch, or after school. Okay. Something that I will do is, so next Wednesday, Thursday, Friday are makeup days. So if you need to make up any tests, recover any tests, those are the days to do it. If you for some reason miss that Tuesday dates, then you can make it up one of the 3 days after. Yeah.
Will we be taking attendance on Wednesday?
No, these are just makeup days. There will be no attendance taken on these days. Okay. Technically, I think it's first, second, and third period makeups on Wednesday, 4th, 5th, and 6th on Tuesday. That's our Thursday, and then 7th period for Friday. But I think they're going to let us be flexible. So if whatever days fits into your schedule, you can just come and let me know. We can show up any of those half days to make up any test or quiz you need. Or sorry, make up any. Yeah, if there's any quiz, hopefully most students will have finished makeup quizzes, but any makeup or recovery tests. And also, I'm going to be grading your Unit 4B test Tuesday afternoon, but I'm just going to give priority to. I'll just flip over through the test, and I'll just grade those that feel like they could be in danger of being below 75, because I want to let you know if you make below 75, so that I can get that test back to you, so that you can, if you wanted to do a recovery, you can recover up to a 75. So, and then the rest of the test I'll grade during the break, but I'm just going to let you know if you make below a 75 by Tuesday, so that you can make your plans accordingly, whether you want to do a recovery for that test. Okay. All right, any questions about our schedule? Okay. All right, so let's go into 4.23. Oh, and by the way, no calculator on this test, but I will give you a formula sheet. Okay, so the formula sheet will have everything that you need. It'll look like the back page of your packet, but I'll give you a blank in a circle. Okay, a blank in a circle. Okay, so 4.23, we're gonna go down the odds, odd number problems. And then we can touch on 4.24 as well. Okay, it says solve the equation for the variable on the interval from 0 to 2 pi. So we want to list out all of the solutions. If it's that includes 0, but it'll be but we're not going to include 2 pi in our answer set. Okay, so this seems pretty straightforward. We can just try to combine like terms and solve for x. This is not going to be anything special in terms of any identities that we need to involve. So I'm just combining like terms there, add sign to both sides. So if I added one sign from the right side to the left, sin x plus sin x is 2 sin x. Okay, so now I can just try to get sin x by itself. So where's sine negative? Which quadrants? Yeah, third and fourth. It's going to be in that pi over 4 family. And those are safely inside my interval. Okay, number 3, this is where we're going to have to rely on one of our identities here. Okay, cosine x minus pi equals √2 over 2. Hopefully we can recognize this as a sum and difference identity and pick that off of our formula sheet and apply it. So I'm going to use the cosine A minus B, right? Okay, try that. One thing I do want to point out is I feel like I've seen some students want to carry that negative into the b value, but notice that negative is outside the b value, right? That negative is just going to correspond with changing it to a positive. But we want to make sure that we don't put cosine of negative pi or sine of negative pi, right? It's that your a and b value are always positive, despite what the sign is. And that sign is just telling you what to do with that middle sign. Does that make sense? So some of these we have to leave alone, but some of these we can reduce, right? We can clean up cosine pi and sine of pi. We know what those values are. So what's cosine of pi? -1, okay. And what's sine of pi? 0. So that's good. That makes it go away and cleans up our equation a bit. So I'm just left with negative cosine of x equals √2 over 2. If I move that negative over to the right side, then I get cosine x equals negative √2 over 2, and that's in the pi over 4 family. Which quadrants? 2 and 3. Any questions with 3? Oh, and by the way, the back of your packet has all the identities, so you can always look at those as well. So we're going to apply our sum and difference identity twice. We got the sign of A plus B, and we also got a sign of A minus B to expand. So try those steps. Okay, so here, if I see, I can try to replace all the cosine and sine of power 4, but I'm trying to save a step here. You see how this is cosine of x sine of power 4? What can I do with these two terms? Combine, which will just, it cancels out, right? Because they're both positive, so if I subtract 1, I can get them to cancel out. So that will save a step. I don't have to do all that √2/2 because I know they'll just go away. And these are like terms, right? That combine it, but this won't go away, right? These will end up both being positive. The order is different, but I can always adjust it, make it sine x cosine power 4. There's going to be plus sine x cosine power 4. There's 2 of them, so I'll combine these like terms before I replace them or get that cosine power 4 resolved. Okay, just allows me to do some cleanup before I commit to all the evaluating all the trigs. So if I do all the step beforehand, then I'll only have to replace cosine power 4 once. Yeah.
So why don't you bring everything over to 0 like first? And then like.
Okay. Oh, why did I bring it over to equal to 0 first instead of cleaning up first? Is that what you're asking?
Yeah, instead of doing that first step, why didn't you just bring it over to 0 first before doing the first step?
Oh, you mean bringing this over to the left?
Yeah.
Yes, yeah, that's perfectly fine. You're more than welcome to do that. Yeah, so the order is not going to matter. I just, for some reason, I just saw, sum of difference identity. Let me get that out of the way. But you can definitely bring this over first and then, okay, so I think here's one reason that I would avoid doing that. The reason why is if I bring this over to the left, it's going to be a minus sine of power 4 minus x. And then that's going to end up changing that sign because negative has to distribute through that term, and that feels messy. Yeah, so I think it's a little bit cleaner to expand first. That way you have to deal with a double negative and distributing. It feels like additional work. No. Okay, so one thing that we can clean up is that cosine of power 4. So what's cosine of power 4? Or 2/2, okay. So these are both outside the sine function. I can reduce, so the 2 and 2 in the numerator denominator can go away. Okay, so now I can just try to get that sine x by itself. Divide both sides by √2. Okay, do you recognize -1/√2? That's the same thing as what? Yeah. And that's in the power of 4 family, right? Which quadrants? You pass. Okay, fine. Okay, quadrants 3 and 4. Why don't we do number 6, just because it feels a little, we haven't done sum of difference identity for tangent in a while, so let's do number 6. Everybody okay with 5? So here's my sum identity for tangent. Just make sure that you know how to read it off of the formula sheet, right? If I want to do tangent of a plus b, I'm going to take the top operation, right? So plus for the numerator and then the minus for the denominator. If you want to set it equal to 1/1 and just kind of set yourself up, if there's a need for cross multiplying, you can, and that way you can just get things on both sides of the equation without having to deal with the denominator. So you do that first, or you can clean up your tangent power 4. Remember, we can't do any of this, right? We can't cancel anything out here. The plus and minus is preventing us, addition, subtraction is preventing us from being able to clean up as we would like between the numerator and denominator. Okay, what's tangent of power 4? 1, that's nice. It's the easy value to replace. But if I cross multiply, I can get the denominators to go away, and so
Sorry, why does it equal 1/1 instead of 0?
because the equation has 1 on the right side, so I got to hold on to that 1. The 1s cancel out. They're both same sign, so I subtract 1. But here, the tangent x will combine to be 2 tangent x. And divide both sides by 2. I get tangent is equal to 0. Again, my solution set is from 0 to 2 pi. So where's tangent equal to 0? Let's see, y over x, right? No, you're right. It's 0 and y over x, 0 over -1, 0 over 1. So 0 pi and 2 pi. But can I keep all the solutions here? Just what? Just 0 and pi. Yep. 0 is safe, pi is safe, but 2 pi is slightly outside the interval.
Why don't we place 0 and pi?
Because at the top of the page, the interval is from 0 to 2 pi. 0 is brackets, so that means we include 0. 2 pi is parentheses, so that means we get close to 2 pi, but we never reach 2 pi. Okay, back page, number 7. Now it says find for all values. Okay, so solution. So that means we have to do this plus 2 pi n, where n is an element of an integer for all of our answers now. There's no identity to apply here. We can just try to get that secant by itself. What's next? Yeah, but I feel like identity sometimes, in this case, will make it more complicated. Yes, yeah, so I did that. I divided by 3. What's after that? Square root, yeah. So yes, to your point there, we do have an identity for secant, but it's not going to get us any cleaner than this, right? So I'm almost at my solution. I can just take the square root and just get that secant down to something that I can recognize. So if I clean this up, that's saying secant of x is equal to plus or minus 2 over square root of 3. Now, this may not seem as familiar, but what if I flip both sides? What's the reciprocal of secant? Both sides. What's the reciprocal of 2 over root 3? So if I flip one side, I can be free to flip the other side, and this feels a lot more familiar, right? These are the same things, but we recognize this a lot easier because we're used to sine, cosine, tangent. Okay, so all 4 quadrants is in which family here? 5 or 6. And each of these we can do plus 2 pi n. That will get us all the infinite numbers of solutions that will keep repeating itself. Thank you. Okay, number 9. Apply your sum and difference identity. Sine to the power 2 is just 1. Cosine to the power 2 is 0. Anything times 0 is just 0, so that goes away nicely for us. So where's cosine equal to -1? Pi. Okay, 11. Don't hesitate to ask questions. I'm kind of going through this fast because I feel like we've seen this before. But if you're stuck at any point, just raise your hand. I can re-explain and slow down if you need me to. Okay, we have two identities that we have to apply here. We got that sum identity for tangent, and then you got that sum identity for sine. There's something we have to be careful about with this too. You know what that is? What happens after we do our sum identity? Where's that 2 going to go? With both of them. Okay, there's going to be two terms. That plus sign means we got to distribute that 2 through. So the 2 is going to go in front of the first expression, and it'll also need to go in front of the second. So I need to distribute that 2 through. Okay. The tangent has a denominator, but it will clean up nicely for us. So don't worry about that. Just apply those identities, and I'll go through the steps. I just want to show you why that 2 gets distributed, because if we were to expand this out and that 2 is still sitting outside, has to go and involve both my terms. I'm going to clean up as I do this. What's tangent of pi? Yep, good. Tangent of pi is just 0, right? Y over x, 0 over -1 is 0. So that's nice. That makes that denominator just go away because I'm just left with a 1, so I can just basically not have a denominator. Cosine of pi is -1. Sine of pi is what? 0. That's nice. That takes that away. Okay, so we're still stuck at a point where we don't have the same trig function. So we have to kind of force them to be the same. So what can I change? Okay, so sine over cosine, right? But there's a denominator, which means, yeah, common denominator. I need to get that to show up for me. Okay, what's my common denominator? Cosine x. Let's see what fractions I need to balance. The first one is good to go. Keep the top. The second one is missing cosine x, so I need to multiply to the top. Okay, so here's what I have. Sine x minus 2 sine x cosine x all over cosine of x is equal to 0. Now, I want to know where this fraction is equal to 0, but the only place I need to look is where? Just the numerator. Yeah, the denominator is different. If I said the denominator equal to 0, then I'm looking for a vertical asymptote, but 0 is not a vertical asymptote. It's just the x-intercept. So we only care about the numerator if you're dealing with a fraction, and if there's a variable in the denominator, we ignore that denominator variable. We only care about the numerator. Okay, so I'm just going to focus my attention on the top here. So let's treat this like a brand new problem here. How would you start this process? GCF? Yeah, what's our GCF? Sine x. Okay, so if I take a sine x out of both terms, that means I'm dividing by that GCF. So what comes first? 1. Sine over sine is 1. Minus 2 cosine x. Set both equal to 0. Subtract 1, divide by -2, I get a positive 1/2. So sine is equal to 0 at 0 and pi. Cosine is equal to 1/2 in the first and fourth quadrant. Because if I subtract 1, I get a -1 on the other side. So -1 divided by -2 is positive 1/2.
Also add, x equals 2 pi.
You could, yeah, but that 0 plus 2 pi n takes care of 2 pi. So it's duplicate, but you wouldn't be wrong if you added 2 pi in there as well. Okay, let's go to page 22. I want to talk about this strategy when you're dealing with a sine or cosine or trig function with multiple angles that's higher than double angle. So we can definitely split that up into x plus 2x and use some identity. But here's another strategy that we can work to deal with this, 3x, 4x, anything that's larger than 2x inside your trig function. Okay, so. And the way we do this is we treat 3x like theta or like x, and we just try to get that 3x by itself. Okay, so if I want to get 3x by itself, I can just move that sign, and that sign will become what? Inverse sign, right? So anytime I want to move a trig function from one side to the other, I involve inverse. So 3x equals inverse sine of 1. Okay, so in other words, we can list out the solutions where sine is equal to 1. Okay, that's what inverse sine is. Inverse sine is just looking for angle measures. It's asking what theta value will allow sine to be 1. So where is sine equal to 1? Pi over 2. And not 3 pi over 2, right? However, we want to add more than just pi over 2, because what's going to happen is it says find all the solutions from 0 to 2 pi. Okay. 2 pi over 2 is the only solution right now, but what's going to happen is we got to divide by 3. And when we divide by 3, all of our solutions are going to shrink. And if it shrinks, that means there's more solutions that we can be looking for outside of 2 pi, because we want our solutions to all be there after the shrink happens. So I'm going to keep adding 2 pi to this so I can go past the 2 pi mark. So when I divide by 3, I can get all the solutions that will exist after the reducing. So if I add 2 pi, that's the same thing as saying pi over 2 plus 4 pi over 2. So what's next that comes up? 5 pi over 2. Okay, so I'm going to list out more than I need, just so that I can make sure I have everything once I shrink everything down. Okay, so if I keep adding 4 pi over 2, what's next? Pi over 2. Yeah, let's do a few more just so we can just make sure we cover everything. What's next? Let's do one more. 17. Okay, this is probably more than we need, but we can decide after the dust settles. Now, I want to solve for x, not 3x. This is what 3x is equal to, but they're going to shrink because I'm going to divide by 3. Now, dividing by 3 is same thing as what? Multiplying by 1/3. It feels a little bit cleaner if I just multiply everything through by 1/3. I can just multiply the denominator by 3. Okay, let's see what happens. So I like it when there are ones that are outside the interval, because then I feel, there's a peace of mind that I didn't accidentally not go far enough, So which of these solutions are outside my interval? What's greater than 2 pi? 17 over 6 definitely greater than 2. Anything else? Yeah, because 12 over 6 is 2, right? So 13 over 6 is more than 2. So I like it when I have more than enough, because I know I didn't miss anything. Okay, so here are my solutions. I can also reduce this down to 3 pi over 2 if you want, but you can leave it as 9 pi over 6. So that's a strategy to deal with multiple angles. You ignore that multiple angle. You list out all the solutions, and when you divide after it shrinks, you want to make sure your solution lives are all inside your interval. Yes, question?
Why couldn't you just do like sine of x and then sine of 2?
Yes, that's another strategy. We could go through that double angle, but sometimes that requires more work because you got to work on a lot of different. You got to do a lot of substitutions with identities, and this is just another strategy to deal. I want us to practice with this, so you have multiple paths towards your solution. Okay, let's do one more. Okay, let's do number 3. Okay, secant of 2x, we don't recognize that. very much, right? But is there something that feels more familiar than secant? Yeah. So if I flip this, it becomes 1 over cosine. But let's just say that I flip it, right? So the reciprocal of secant of 2x is cosine of 2x. What's the reciprocal of -2? 1 over -2. So what if I just flip both? Then it just feels more familiar because whatever I do to one side, I can do to the other side. So 1 over cosine x equals to -1 over, or -2 over 1, which if I flip both sides, I get cosine 2x equals -1/2. Okay. I'm going to practice using the multiple angle identity here, or multiple angle strategy. So that I'm going to bring this cosine over. Just try to get that 2x by itself and just get that inverse cosine to show up. Okay, so whenever I see inverse cosine, I'm just thinking, okay, that's really a way of saying theta. Okay, I'm looking for theta here. In other words, what theta value will allow cosine to be -1/2? And we can list out all those possibilities. Okay, so in the second and third, right? So 2 pi over 3. What else? 4 pi over 3, right? Now I want to add more than what I have because they're going to shrink. So I'm going to add 2 pi to this. Now I want to make it so it's easier for me to add the fractions. What's a variation of 2 pi that will be easier for my fraction here? 2 pi, same thing as what? 6 pi over 3. So I'm just keep adding 6 pi over 3 to both of these, just so I can get some variations here. So with each one, and I've one in the first, second, and third quadrants. I'm just keep adding each of them to 2 pi or 6 pi over 3 until I feel like I have more than enough, because they're going to shrink. Multiply by 1/2. And then once the dust settles, I can figure out which ones I want to keep. Okay, so which of these solutions is more than 2 pi that I can remove? Yeah, anything else? Yeah, because we know 12 over 6 is 2, right? So anything more than 12 over 6 is going to be, is not outside, is outside the interval. So there we go. If you want to reduce these, you can. Or leave it alone. Either is fine. Okay, so that's good. We've covered pretty much all the new topics. We're just kind of going to go through and continue working on the worksheets. I can give you a test review worksheet early tomorrow for those of you who want to take it early. So I'll give you those. I'll make all the test reviews available so you guys can pick it up. And if you want to study or look through it beforehand, before Tuesday, you're more than welcome to do that. Okay, come up and get your phones. All right, so your solution right now is actually here's the power here. Divide by 3. So all these values. If we want to go sort of like non-quantified, so we get strings, we get the land. Oh, co-terminal angle.
I haven't thought about it very. I'm just thinking to be like, well, listen, I'll do this for you, probably.
That's too high. I'm not gonna get the same high. Can't get a comment down me. So I'm adding 4. So I keep adding 5, 4, 5, or 2. That could be, increasing as well.
Like literally, not a total feeling.
Zero or is 0, 0 is an option.